An op-amp limiter, how to limit the amplitude of amplified signals. Circuit diagram analysis. First, let's look at how the circuit works. We'll just cover the basic concepts here. You can explore the functionality in greater detail via simulations. The nonlinear amplitude control is achieved, not surprisingly, by incorporating the nonlinear current voltage characteristics of a diode. When the output voltage is low, both diodes are reverse biased. This means that we can analyze the circuit as if they aren't even there, and when we do that, we see that the limiter is just a typical inverting op-amp with some resistors connected between the output and the supply voltages. As expected, then, the limiter is just a normal amplifier as long as the output is not high or low enough to provoke its limiting functionality. As the output increases, though, the voltage at the anode of D2 starts to increase relative to the voltage at the op-amp's inverting input terminal. Eventually the voltage across the diode will reach 0.6 V, and the diode will begin to conduct. With D2 conducting, RF is bypassed and the op-amp becomes a voltage follower. In other words, the gain is reduced and the output amplitude is limited. This behavior is shown in the input voltage is decreasing, and consequently the output voltage is increasing. The voltage at the anode of D2 is also increasing, and when the input voltage reaches about 0.4 V, the voltage across D2 is high enough to make the diode start conducting. The voltage across D2 then levels out, as we would expect from a forward-biased diode. The next plot confirms that the output voltage also levels out. An analogous process occurs with diode D1.